Hello, Brainiacs, and welcome to math. Today, we're going to be exploring multi-digit multiplication because I can solve and understand multi-digit multiplication and division problems. In today's learning, we're going to be zooming in on how we can use area model to solve multiplication problems for up to 1-digit by 4-digit numbers. In our multiplication learning, our big goal is to have a deep, concrete understanding of what, how, and why we are solving our multiplication processes. To help us with this, we learn a variety of different strategies, and ultimately, students will select the process that they are most successful with. In today's learning, we're going to be practicing the area model. So, let's get started. For today's learning, we're going to be solving 4 problems together. You will want either a piece of paper and a pencil, or at least something to write with and write on. You're welcome to pause the video now to go grab those, or wait until you see the problems, and then we'll get started. The 4 problems we will be tackling today are 42 times 9, 136 times 5, 945 times 6, and 2,407 times 8. At this time, go ahead and grab something to write with and write on, and pause the video and try and solve these problems first by yourself. Welcome back. Now that you've tried each of these problems on your own, let's go ahead and check our work together using the area model. For each of these problems, it helps to break apart the number into smaller numbers that we are more easily and readily able to solve with multiplication. For 42 times 9, we will take the 42 and break it apart into 40 and 2, its expanded form. Essentially, we're setting up an array and just labeling the parts, and we'll be multiplying the entire thing by 9, or 9 rows. By setting up the problem first, it tells us how many boxes we will easily need. Then we're ready to solve for the area within those boxes. Our first box has 40 times 9. 4 times 9 is 36, but it's not 36, it's 36 tens, or 360. For our next one, we see 9 times 2, which is 18. We've now discovered the area within each of these boxes, and the total area, or the entire space of the array, in a 42 by 9 grid, will give us 42 times 9. For that, we'll just need to add up the different parts. 360 plus 18. For 378. Let's try the next one. We're going to use the exact same process. Break apart our 136 times 5 so that we can solve an array of 136 by 5 by putting it into numbers that we've learned to quickly and efficiently and accurately solve. For this one, since it's 3 digits by 1 digit, we will need 3 spaces. 500, 150, and 30. Again, we can add those up to find our totals. $136 times 5 is 680. For our next one, we're going to use the same process. 945 times 6. In this case, I need to remember everything I've learned about multiplying by multiples of 10 in order to make sure that I'm not missing any of these crucial place values. $5,670 is my total. For my final problem, I now have 4 digits, but my process is exactly the same. Break it down into numbers I can more easily, effectively, and efficiently solve. In my tens place, Students might get tripped up when they see a 0, but remember, I'm just finding the value of each digit. This 2 is really worth 2,000, while the 4 is really worth 400. The 0 then, if I have no tens, is worth 0. And the 7, since there are 7 ones, is worth 7. Now that I have 4 digits, I will have 4 boxes by 1 digit, so I will have 1 row to go with my 4 columns. Again, I'm essentially just creating an area model that demonstrates the area that would be taken up by these if they were actually drawn out. So let's go ahead and solve. 2 times 8 is 16, but it's not 16, it's 16,000 because those were 2 thousands. 400 times 8 is 3,200, which is also 3,200. 8 times 0 is just 0. And 8 times 7 is 56. Once again, I'm going to want to make sure I add up my total, making sure I'm very careful with my place values to make sure they line up exactly. That might be a little trickier with my 0, but as long as I make sure my place values are in line, I should still get the correct answer of 19,256. And there you have all 4 problems solved. For each problem, I'm just breaking the problem apart into multiples of 10 that I can quickly and accurately solve, while still maintaining my understanding of where these numbers are coming from. As a result, I am able to more efficiently and accurately solve for multi-digit multiplication problems. The other benefit of using area model is that it works with any size number. I can continue to expand my array both by the number of columns and by the number of rows to accommodate any size number, while still maintaining problems that I can quickly and efficiently solve. By noticing how these numbers line up, I can find the overlap for any grouping. It also helps to think of it in terms of its repeated addition or the array that it's showing. These are the things that the area model is helping me to remember when I'm solving this process. For example, with 136 times 5, I can think about it in the area model, but it's really matching exactly what I'm doing when I'm thinking about it as repeated addition, which is 5 groups of 136. I can see that in my repeated addition problem, I have 5 groups of 6. I have 5 groups of 30, or 5 groups of 3 tens, which is 15 tens, or 150. And I have 5 groups of 100. 5 groups of 100 being 500. However, I've solved it in a much more efficient way. This will especially become true when we tackle multi-digit multiplication that goes up to 2-digit by 2-digit. If you think you're ready to tackle that, let's try one last challenge problem. In our challenge problem, let's try 24 times 12. Again, our process is exactly the same. I'm going to be building an array that will take up 24 by 12. And I'm going to be finding the area inside. But since I don't automatically know what 24 times 12 is, I can break it apart into sections that I can quickly and easily multiply. In this case, 20 and 4. Since I know my multiplication facts times 12, I could go ahead and solve it just like this. 12 times 2 is 24, but it's not 2, it's 2 tens. So 12 times 2 tens is 24 tens, or 240, and 12 times 4 is 48. Adding those together then, I would get 288. 24 times 12 equals 288. However, my process earlier showed me that I could break anything apart into its pieces as long as the total area was still the same. And that's true with our second number just as much as the first. So let's try breaking that 12 apart as well and see how that makes this problem perhaps even simpler. Since 12 is a two-digit number, I can also break it apart using expanded form into 10 plus 2, which still gives me 12 rows going across. I'm just now breaking them into pieces to make them quicker and easier to solve. 10 times 20. I have 1 times 2 is 2, but it's not 1 times 2. It's 1 tens times 2 tens, and I know that 10 times tens is 100. I need to keep those two place values. 10 times 4 is 40. 2 times 20 is 40, and 2 times 4 is 8. For a number like times 12, I may not need this process. However, when we get into a problem like 24 times 92, all of a sudden this will become a lot more applicable. It also allows us to see how this process can transform any problem into problems we can efficiently and accurately solve. For today's credit, if you would like to make sure that you're showing your teacher that you have completed this video, go ahead and write down the final problem that we solved together, the challenge problem, and the answer into the next spot on your planner that your teacher will be signing. That way she'll know you've completed this video. Thanks so much for watching, and have fun doing math.